Here's homework 6, part 1, number 5. Here is the population statistic, which is 0.46, right? Or sample statistic, I should say. Our population parameter is 0.4 from 40%. We've got, that's the same as our mean for this distribution. Our n is 25, there are 25 people, and our standard error is being computed for us based on the population parameter, and we've got our test statistic. We are going to solve this problem using what is called a critical value, which is different than a p-value. The critical value basically just is another z-score. Alpha is 0.1, that's from this part, but it's a two-tailed test, and so half of alpha is on the right-hand side of the normal curve and half is on the left. Let me show you what I mean. Here are our two tails, right? This is the standard normal with the mean of 0 and the standard deviation of 1. So half of alpha is over here, so this is 0.05%, and this is 0.05%. We want to know what the critical value is, and the critical value is the z-score that is right here, that just starts this off. So we can find this using our inverse normal function in Excel. So if I click on this, we'll be able to see it. We have normal inverse 0.05%, 0.1. Notice that this is actually this value over here, the negative value, but the problem is asking for the positive value, so I just put a negative sign in front of it. So this is your z-score for 0.05, and technically this is the same z-score where 0.05 is on the right-hand side, or 0.95 is on the left-hand side. Anyway, so let's make this positive for the problem. I'll put a negative sign in the front here. Anytime we have a two-tailed test, we split the alpha in two like that. This is now our critical number, and the way that we this critical number starts this range, this black spot over here, and this black spot over here. If our test statistic falls in the range, then we will reject the null hypothesis. But in this case, our test statistic is about here. It's like 0.6. So because our test statistic is in this part, we will fail to reject the null hypothesis, meaning that for now we are going to say that the null hypothesis is true. And in this case, what does that mean? That the proportion of men who owns cats is 0.4. We're going to stick with that. We have no evidence to show that that's not correct. Yeah, that's it. If you wanted to, you could find the p-value for this, although it's not being asked. And the way that we would find our p-value for this two-tailed test is we would take our test statistic. Here, let me compute. I'll pause this for a second. So like I was just saying, if we wanted to, we can compute the p-value for fun. It's a two-tailed test. So basically what we do is we find the probability of getting this test statistic. It's a two-tailed test, so we have to think about both the positive and the negative form of that. Either one is really fine. For now, let's just think about the positive form of that. And if we're going to think about the positive form, we have to subtract it from 100. I'll show why in a second. No, it's the same. Okay. So remember, this area here is 0.05. We want to know what is the probability of getting 0.61, so right here, or greater. And is that smaller or less, or smaller or greater than 0.05? So the probability of getting 0.61 is like 27%. So that's our p-value, which is much larger than 0.05. So we would once again fail to reject. So the critical value is a z-score. The p-value is just a probability based on your test statistic. Either way, there's just two different methods for doing the same thing. Yes. All right. Post if you have more questions. Thanks.